If you look, hopefully, oh, change, I may have to go in and out again. Are you looking at the Canvas page right now? Okay, good. So I'll make it a little bit bigger. It's probably quite small for some of you. There we go. So what we have here is closer to what you're going to see on the day of the final. The difference is that the practice final will be missing, but there is a formula sheet. This is the link that you'll use to upload your working. It's just a shell right now, so you can't upload anything. It will become viable on Thursday. And here, oops, typo already. Your exam PDF will be there. If you click on that, there's nothing in it, but when you do on the day of the final, there'll be a PDF that'll open up and you'll be able to see the questions. Based on, since I'm doing this for all my calc classes, based on what one of the other students said, they were thinking that they needed to print out the PDF and then in the spaces kind of write the working. That's not really suitable because not all of you have access to printers for starters. So when you actually get to see your final, it'll just be questions. I wouldn't even leave the space there. The reason why I put the space on the practice final is that some of you might just do that. If you've got a printer, you might print the thing out and just do the questions like you were doing a little practice exam, and then you could go and look at your answers. So it was for that reason. So when you get that, you'll have your 10 multiple choice and your 10 section 2, and they'll be right after each other, so there won't be any gaps. Now, I'll kick in with this one, which is our practice final. Open it up a little bit, maybe see if I can make it bigger. That's good. And I'm scanning down to a question that needed, oh, can I find it? I'll do it on the solution side, that's probably easier. No. Nope. Not that one. Not that one. Yes, it's this one. That is 58, hopefully. -16 and -42. So it's 58. Okay, you had 60. So that one was actually fine. So that was more for Kathy. As you can see up here, you got all the solutions. Thanks to Kathy, it's a lot more accurate than it was when it started. We can't guarantee it's 100%, but at least it's probably in the 90s now. And it's a resource for you. So I'm ready for my next question. Topic. How come you married an American woman? I mean, come on, ask me something.
Could we cover a really horrible series?
Well, there's lots of what horrible looks like. Huh. Okay. Let's see what I can come up with off the top of my head. A really horrible series. Most series tend to be fractions, not all of them, but most of them. So I'd probably put a -1 to the n in. Here's one horrible series. Yeah, that's pretty horrible. What you've got to be able to do when you have a series, if you're not told what test to use, you have to look for some clues. This one is just random because it came into my brain. what would be the best test to use in this particular series?
Alternating series.
Because of that. Agreed? And many times that would have been the correct choice, but not this time.
A ratio test?
Yeah. What makes it more a ratio test and less an alternating? I'll put an alternating series test situation below it.
The n in the exponent?
Yeah. So an alternating series test might have, that kind of look to it, right? So identify the correct test. So this would be an nth root test, or as the book calls it, a root test. This one here, I would say, would be an alternating series test, which I'm pretty sure it is. Right, back to that one. Well, identifying who the test is helpful, but you still have to know what it is. Right, now they stick an absolute value around it, which basically takes care of that. And the nth root, well, what you get is 1 plus 7 over n squared over n. You see, you essentially take out an n from each. And these are all positive, so I guess I don't need the absolute value then. And now you're left with this guy. What would be the limit as n tends to infinity of this one? Because, it's important that you know how to get it. What is the answer to this limit?
0.
0. Can you just brute force this one? So if you do a brute force, it's 1 plus 7 over infinity squared over infinity. Well, that's 0, and 1 plus 0 is still 1, and squaring 1 is 1. So you get an answer, which is fine. In this case, 0, which is a good answer. Isn't the third part the test? Does that mean that this series converges, or does that mean this series diverges, or does that mean that this series is inconclusive, which means we don't know? What does a limit of 0 in an nth root test mean?
It's absolutely convergent.
Correct. And the absolute, I'm glad you mentioned that because I forgot. In fact, isn't the test as long as you're less than 1? You're absolutely convergent. So if I'd got a limit of a half or 3/4, that would have been fine as well, wouldn't it? The alternate is that you get greater than 1, which is just divergent. We don't have different flavors of divergent. There's not a thing called absolutely divergent, for instance. It's just divergent. And if it was equal to 1, not good. So this question would be a multiple choice question, in my opinion. And what would my answers look like? Well, one of them would be divergent. One of them would be convergent. One of them would be absolutely convergent. What's the other kind of convergence? You can be convergent, you can be absolutely convergent, right?
Conditional?
Yes. So you see, I could pretty much do that to any series by just giving you those 5 choices, because isn't one of those 5 choices going to be true about every series in the universe? And your technique for finding it is really, there are other ones to do it. Now, if you were conditionally convergent, to remind you what that would be, a conditionally convergent would be the untouched series, maybe this one, converges. But when you make everybody positive, it diverges. A good example of a conditionally convergent series would be that one. That is an alternating series and it does converge. If you make everybody positive, it now diverges. So this series, the original one, is called conditionally convergent. Well, let's look at this guy. From a multiple choice strategy. Certainly, if I was doing it the formal way, it would be this, and it's not that lot of work, right? You should be able to get it. But there are other cruder ways in which you could come up with maybe the same answer. Any ideas how you might tackle the problem of which one of these answers this series is? If you go to your calculator, you can look it up, but there is actually a way to get your calculator to add up the first 100 terms. And if it's going to be a nice convergent guy, right, in which case an absolutely convergent in this case, wouldn't you get an answer like 8.22? And if it was going to diverge, wouldn't you get an answer like 22 billion? You could just do a numerical. It's not very successful because you have to learn how to do your calculator and make it do a series, but you can look it up if you're interested in it. So that would be how I would, another way I could do that. I could probably do it by an argument, something like this. It's not a math argument. Would you agree that n to the power of n is massively big really quickly? Which means won't that get really small really quickly? And don't converging series tend to do that? So at least I'd be able to say it's convergent. I'm not sure if it's absolutely convergent, but if I take that away, wouldn't the same argument still hold? And so I would go absolutely convergent, right? Convergent, absolutely convergent. Did you have an idea of your own horrible series, or is that one ugly enough? I'll move on from this in a few moments. I want to give you some I'll call them number 1, number 2, number 3. Which one of those 3 series would it be a ratio test situation? Which one of those 3 would you use a ratio test on?
2.
Number 2.
Right, correct. What's the clue?
There's factorial.
Tends to be ratio test, agreed. Which one of the 2 that's left would probably be an alternating series?
3.
What's the clue? Correct.
The -1 to the n.
Right. Shouldn't all alternating series have a -1 to n plus 1, something like that? Last question is hardest of the 3, I think. What technique would you use to find the top one?
Comparison test?
Yes, not the limit comparison test, but the comparison test. And you would do the comparison test by proving that this guy was less than that guy, which was less than that guy. In which case, if you're less than a converger, you converge. And that again would be a really good multiple choice question, because you can do a comparison really quickly. And hopefully you recognize that as a P series, P equals 3, so it converges.
Could you go over the difference between the limit comparison test and the comparison test?
Yeah. When you have nothing but polynomials, even polynomials with square roots in them, you will use the limit comparison test. For instance, in this one here, the original series is the untouched version, which is this guy. And then you do some surgery on it where you keep the highest power top and bottom. And you will use that as your comparison. And the limit comparison test, you find the limit of AN, the original, divided by the comparison one BN. And as long as that's a number, right? Not infinity, right? But it can be 5, it can be a fifth, right? You know how a lot of tests, if you're bigger than 1, it's divergent, and if you're less than 1, it's convergent. That's not true with the limit comparison test. The limit comparison test just says, is it 4 or is it a quarter? As long as it's a number, they both behave the same way. In this case, would you agree that this one is divergent? It's a P series, it's a harmonic one. Even if it's weird ones like this guy, you'd call the top the square root of n, you call the bottom n squared. That becomes 1 over 3 over 2. That's going to be your comparison guy. And that one also converges. So when do you do just, these are all limit comparison tests. When do you do a comparison test? When one of the two terms, almost always on the top, is not a power. It's a weird guy. A weird guy could be e to the power 1 over n. Right? That would count as a weird guy. You would do a comparison test on that. We've done a sine squared. You could do an inverse tan. When the top's not a power, right, or a square root, then you're thinking comparison test. Now, in the comparison test, all you need to do is take this guy and prove that he's bigger than something if you know it converges, or prove that it's less than something if it diverges. Now, although I do not know what e to the 1 over n, because it keeps changing as n gets bigger, would you agree that its biggest value is 1? Now you can put it in, right? E to the 1 gets you e. So I guess I could say its biggest value is e, now that I've thought about that, but 1 will do. You can then look at this guy and basically say that, and that converges because it's a P series. That is less than this fella, so he can put, that guy there is pi upon 2. Right, the inverse tan of infinity is pi upon 2, so you can be pretty sure it's less than. So the limit comparison test is when the top is not a power of n. It's probably the least used test we ever did. You probably only see a couple of them, because there's not too many situations, is there, when you look at it, where the top is ugly, that it's not a power of n. Typically look at the bottom, because that's going to tell you what's the case. I'll give you an example of what I mean. If I went and said to you, inverse tan of n over n plus 1, or if I said to you, inverse tan of n over n squared plus 1, this one's going to diverge. Sorry, wrong way around. This one's going to converge, and this one's going to diverge. The top, although it's ugly, typically is just going to be in a range of values, right? It never gets bigger than this, and it never gets less than that kind of thing. So this guy here, would you agree it roughly behaves like a 1 over n, and that's why I know it diverges. And this one, on the other hand, roughly behaves like a 1 over n squared. And so I know that it's going to converge. And all you need to do is, if you know it diverges, you just have to prove that this guy is bigger than a version of 1 over n. Now, I know pi upon 2 is that guy, so I'd probably get away with saying that. If I was going the other way, I just need to prove that it's less than this fellow. And I could probably get away with pi upon 2 over n squared. I might have to tweak it, because when you take 1 away from the bottom, if you make the bottom smaller, the whole answer becomes a little bit bigger. So, you know, if you want to make it safe, you would do a 4 there, and if you want to make it safe, you double it up. But that's just tweaking. You're still basically knowing it's going to converge or diverge. So I probably said more than I needed to there, but that's the difference. Okay, where's our next guy?
Can we look at section 13.1, number 14 from the homework?
Sure. Give it some room. 13.1, I think you said number 4?
14.
14. Okay, is that a short one, or will I have to go and open it up? I can't hear you, Nicholas.
You might want to look at it.
Okay, so give me a few minutes to open it up, and I'll let everyone see it once I've got that. Okay, what the heck are you doing? I'm having my usual, the thing's not behaving. Okay, 13.1. Oh, it's vector functions, gotcha. And 14 is the second and last one, so that should be kind of interesting. Okay, I'll just write it down for you. What you have are 2 space curves. First space curve is a t squared, and a t cubed. Oh, I remember this guy. And the second space curve is this one. And I've changed it, which WebAssign really should have done. And I'm giving it its own variable. In WebAssign, both of these were t. And we're trying to find the points in which these paths intersect. Now, if you imagine this as being R1, and this guy here being R2, the intersection would be these 2 points here. And got to imagine this is 3D. So can you imagine, not only do they look like they cross, they physically do go through each other, right? Because can you imagine side on, you could have a curve like this and another curve like that. But if you drew it looking vertically, it could look like they're crossing, right? And they're not, they're more like skewed. So we're assuming that these cross, and we're being asked to find the smallest x value for where it crosses and the largest. So if you take the x coordinates, t will equal 1 plus 4s. If you take the y coordinates, you get t squared equals 1 plus 16s. And if you take the z coordinates, you get t cubed equals 1 plus, in my example, 52s. So really what we've got to try and do here is to solve a system of equations. And what makes it a little bit harder is that they're not all linear. If they all look like number 1, you could have done that using the math, systems of equation math from Math 94 and 99. But I can still do it. Can't I use this guy and substitute him in here? So I'm going to put that t equals 1 plus 4s into equation 2, which is this one. So that gives me 1 plus 4s squared equals 1 plus 16s. And so I've reduced an equation with two variables into one with only a single. This gets me 16s squared plus 8s plus 1, and it's still equal to that. If I subtract 1 and 16s from both sides, I believe you get that. If I pull out 8s as a common factor, I get 2s take away 1. And that gives me s equals 0. And this one gets me s equal to 1/2. Now I know the s values. I can find the coordinate of the point when s is 0. And I'll do that in a moment. And then I can find the coordinate of the point when s equals 1/2. Okay, when s equals 0, you get 4 plus 0, which is, so there's a curve, 1, 1, 1. And when it's 1/2, you get 1 plus 4, that's 2. So 1 plus 2 is 3. 1 plus 8 is 9. And 1 plus half of 25, 26 is 27. And that would be the coordinate of the intersection where the x was small, 1, and this would be the other one. So this would be like the point 1, 1, 1, and this would be the point 3, 9, 27. Now you might be thinking, well, that's what you get when s equals 0, but what about the second one? What about t? Well, when s is 0, isn't t 1 plus 4s, which makes t 1? And if you plug t equals 1, you get 1, 1 squared, and 1 cubed, which means you get that point. Right, so they match. And the other one was what? S equals 1/2. And if you use it in here, t will equal 3. And if you plug 3 in here, you get 3, 3 squared, 3 cubed. So you see it matches perfectly, doesn't it? That you found 2 points that match. Now, what was the problem? And it's WebAssign that did the no-no here. WebAssign did that. And that was a no-no, because if you want to call this t, aren't you going to match t's with t's and it doesn't solve, right? I don't know if you would even expect to be able to realize that that's what you had to do. So I don't think it was a fair, I get things wrong all the time, but even WebAssign gets things wrong sometimes, right? They could have written that question a much clearer way. I hope anyway, if you saw it with the S's and the T's, that you were more likely to do what I just did here. If you did it with the T's and the T's, it ends up being unsolvable, I think, right? It doesn't work. And so you might say, well, what's the difference? How come these overlap or intersect, whereas if you do the T's, can you imagine that the first one flies this way and the second one is flying this way? But couldn't this one reach it, right? The first curve reach it at the 4-second mark, and the other one reach it at the 5-second mark. It's like watching an air show where 2 aircraft intersect but don't crash into each other. What I'm saying is that their pathways cross, but at any given point in time, the aircraft are not at the same location. Now, if that question had been, where do they intersect, and it was meant to be like a crash situation, then you would have made these the same, right? You would have made both of these T's. And you would have found, if that was the case, that maybe one of these 2 points actually did crash into each other, but in the other one, you know, one passed and then later on the other one crossed over. So, kind of cool question. So who's next? What's our next topic or question or whatever?
Could we do one of those problems where they do intersect and crash?
Yes. Now, in that situation, it is correct to use T in both cases, because don't we want to look at where the thing is, right, its pathway, but don't we also want to know when it is where it is, right? So using T in both cases. So I'm going to do a T squared, and a T cubed. And I'm going to cheat for a minute. And I don't want you to see the cheat because that'll kind of take away the fun. There we go. These two space curves are actually going to crash into each other at least once. I've made sure it's once. So you would take the x coordinates, which is this one, and you'd take the y coordinates, which is this one, and you take the z coordinates, which is this one. But have you noticed that this question algebraically is a lot easier to solve? Because don't we only have one variable? So if you take equation 1 and solve for t, what do you get? Well, if you take 2t away from both sides, you get that, and t equals 3. And can you trust me that if you plug t equals 3 into the first space curve, you'll get 3, 9, and 27. And if you plug t equals 3 into this one, the second one, you get 3, 9, and 27. So the point where these two intersect, right, crash into each other, is that single point there. Right, you still match the x's, but you solve. But in this case, don't you have a lot less work to do because you only need one equation. Now, can you imagine a different situation where I got, say, something like that, right? Suppose when I matched the x coordinates, I got that. That gets me so that would be t equals 0, and this would be t equals 1. Now that might mean that this pathway crashes twice, right? It hits it and then, you know, somehow it never gets destroyed and then it hits it again. Of course, it might not mean that. What happens is that you should check by matching the y coordinates. And if I match the y coordinates and I found out that 2t plus 1, what's that be? Was that. If you try t equals 0 in here, do you see it doesn't work? But if you try t equals 1 in here, it does work. That now means that this here is a phantom solution, right? It doesn't work all the time, whereas this one does. We'll assume that I checked the third one and they matched, right? Now, suppose I checked the third one and it didn't match. then wouldn't your answer be that these two space curves never crash into each other? They may intersect, right? They may overlap, but not at the same time. And that would be your answer. Kind of next question. Oh, could you imagine just an application of that? Can you imagine that they've discovered an asteroid away out in space, and they've taken enough observations to put a space curve through it? You get computers to do, right? You pick 1,000 observations, right? You know exactly where it is over 1,000 units of, every minute, right? For 1,000 minutes, you record its location. So you've got your asteroid and it's doing whatever it's doing, right? And you've got the Earth, and the Earth is moving, right? It's going around the sun. And so we pretty much know the space curve for the Earth. And you do the space curve for the Earth. Now, wouldn't you like to know if either of those two were actually intersections? And by that, I mean that the asteroid and the Earth are there at the same time. Because couldn't the Earth pass by and then 2 months later, the asteroid, goes through the same pathway? So in a question like this, wouldn't you want both T's to be the same? And then you might say, it's a near miss asteroid, it misses us by 20 million miles. I don't know why 20 million miles is a near miss, but evidently it's better news than this thing hadn't a chance of a snowball's chance in hell of ever being us. And that's probably not much news, right? Because every day, couldn't you say, hey guys, there's another asteroid that's not going to hit us? Right? I mean, that would get boring after a while, so people wouldn't pay attention. So they have to say, we have a near miss one. They even have some really scary ones. Don't they call them things like the Death Bringer or something, just to frighten you? And according to what I believe, if an asteroid gets closer to us than the moon does, it's a near miss asteroid. And the moon, some ridiculous distance away from us, really. Yeah, it is. So I don't think we're going to be killed like the dinosaurs anytime soon. Although I think that was a comet, not an asteroid, but whatever. Next question. I've drifted. Try to focus back. Last question, actually. Or maybe we don't have one. Okay. Well, before you go, can I, since this is like the last chance we'll be able to have a kind of social conversation, it has been fun. I know I will see some of you on Monday, but not all of you, because if your test grades are great, you probably don't need to do test 5. You will still get attendance, because I'm assuming you're just doing revision for your final instead. Okay. If you do turn up, it's the classic rules, so I won't need to tell you about them. You know the rules of what not to do and cheat. And I will be sending you out. I'll try my best to send you out. It'll probably be late Monday, your last grade, because I've got to grade the thing and put it in a spreadsheet and do all sorts of cool stuff. So by Monday, late evening, you'll know exactly what your grade is. I will also put on that last letter, do you know the little email thing I send out with your grades, what you need to get a 2.0, a 3.0, or a 4.0 in the final 300 points. So you've got a kind of, I need this or I need that kind of goal. And with the exception of Kathy, most of you liked my jokes. It really has been fun. I don't know why I always feel sad at the end of classes. Like, It's not like anybody's dying, right? I mean, you're all going to have a great life and I'll see you around. But drop in and see me in my office, right? Because I have free candy. And if you bring candy, they shall come, right? So don't be a stranger. I'd love to find out what you're doing in your life. And Emma, drop in and tell me about that new university and how much fun it is. And Noah, you can tell me all about earthquakes and volcanoes and what you're learning. That'll be interesting as well.
Absolutely.
Okay. Bye-bye, guys. I will see some of you on Monday, and I will see all of you on Thursday.
Thank
Have a good one.
You too. Say hi, obviously, if you haven't done so.
Thank you.
You're welcome.
For test 5, are we going to be able to use like those graphing platform websites?
Yes.
Okay. And for the final?
Yes, you'll be able to use them for that too.
Okay.
Okay, well, have a good finals week.
Yeah, well, I'm going to have a much easier finals week than you. Well, let's be honest. You're going to be stressing and doing what you need to do, but you've been there before, so you'll live, right? Yeah, I'll have a relatively nice final weekend. My job is to write that final and then check that there's no mistakes in it, which takes me longer than writing the darn thing. So that'll be my weekend. Obviously, that's nowhere near as stressful as yours. So have a nice weekend, or as nice as you can have. Any other questions?
So I kind of missed the entire beginning. I kind of just moved and my computer and internet has been freaking out. So I missed the entire beginning of this call.
Okay, so what we were talking about here is just some practice questions. So watch the video and you can catch up on the beginning. And I'm assuming that you know that on Monday, the test is optional. If you've got 4 good homework grades, since I only count the best 4 good test grades, I only count the best 4. So if you're good there, then you don't need to do that one. And if you want to improve your grade, because you know that at least one of your tests is a bit in the low side and you think you can do better, then you should turn up on Monday. And what else did I mention? I'll be sending out late Monday your last report, so you know exactly what you need for the final to pass and get 4.0. And the earlier part was just people going over various homework questions or puzzles that they're having trouble with. If you watch the video of this, you can catch up on that.
Okay, thank you.
You're welcome. Any others?
Yeah, I just had one question about a partial derivatives homework question.
Mm-hmm.
So it was actually 14.3, and more exactly, it was number 16.
Number 16?
16, yeah.
Yeah.
And if you want
could
me
you
to just read
yeah,
it?
go for it.
Yeah, so it was f of x, y, and z equals e to the power of x, y, z, which is then raised to the power of 9.
Let me put it on the screen so you can verify what you said is what I think you said. So it was this one, all raised to the power of 9?
Power of, yeah, actually the 9 is just on the, inside the parentheses. It's not in, yeah, right there. I don't know if it makes much of a difference, but.
It does. That means only the Z gets it. The one I just did means everybody gets it.
Oh, wow.
So it's X, Y, Z to the 9. That's what it looks like?
Yep.
Okay. What kind of partial derivatives are you being asked? First, second, any particular one?
Actually, let me just look it up. Yeah, I wrote it down. I don't.
I can do a first for you while you're thinking what it is. Right, let's suppose you're doing this one.
Oh, I have it right here. It's asking for the partial derivative x, y, then z.
So it's a triple, that one?
Yep.
Okay, so that means do x1, do y2, do z3. You know it doesn't matter because of Clairo, but we'll do it in that order. So first thing I'm going to do is a partial derivative with respect to x, which is that guy. Now, if you differentiate e to the x, y, z to the 9, you get e x, y, z to the 9 times the derivative of this with respect to x, which basically just means that guy. So we now have y, z to the 9, e to the x, y, z to the 9. Are we okay with that one? Now, if we move on to the next stage, we're going to now take this but differentiate it with respect to y. And the way I see this thing is it's now a product rule, because there are two distinct positions where the y is. And so if I'm differentiating something with a y times something else with a y, it's going to be a product rule. So I'll use the generic product rule formula, and I'll call this f and I'll call this guy g. And you differentiate this with respect to y, you get that, and you leave this alone. Plus, you leave this alone, and you differentiate this guy with respect to y, and that gets you EYZ to the 9 times the derivative of XYZ to the 9 with respect to y, which really just gets you that guy. And so what do we have now? Well, we have a Z to the 9, this fella, plus that and that is a bit messy, but you essentially get that guy. So far, so good. Now, the next one is just horrendous. I can tell it's going to be horrendous. Because now I need to differentiate this with respect to Z. And when I look at it, I'm saying product rule for this guy, a different product rule for the other guy. So I'm going to have to do two really ugly product rules. So let's look at this one. Yes.
Can you factor out e to the x, y, z so you could just do 1?
You could. Yeah. It's still going to be ugly, but it's slightly less ugly. Now, I could also pull out a Z to the 9, but I suggest you don't, because it actually makes the question harder than easier. So it's going to be one massively big product rule rather than two slightly smaller, ugly product rules. So now we can do that guy. It's going to be f dash g plus f of g dashed. With respect to z, if you do this guy with respect to z, you get a x, y, z to the 9 times the derivative with respect to z, which is actually a little bit different from the typical answer. Plus, not plus, times g. Plus, leave the first guy alone, times the derivative of this, and that gets you that guy plus that guy. So our answer is basically these two things added together. Since they have that common factor, x, y, z to the 9, I'll do that so I can forget about that. And now I've got this plus all of that. So this times this gets me 9xy z to the 17. This times this gets me 9x squared y squared z to the 26 plus this guy plus that guy. if I'm being really fussy about it, I think I can get a z to the 8 out. I'm not sure that's going to help much, but
I have a question about the
Yeah.
so the very last portion, the 18xyz to the 19th.
Yeah.
Shouldn't it be to the 17th power?
let me check it. Yes.
Okay, thank you.
If I pull out the z to the 8, I get 9xy z to the 9. I get a 9x squared y squared z to the 18. I get a 9, I guess that's something. And I get 18xy, 17 leaves you with a 9. Whoa! Those two guys can combine. So I get 18xyz to the 9, a 9x squared y squared z to the 18, and a 9. Oh, might as well pull out a 9. I can't see any more style points. That's as good as I can make that guy. Which is one downright ugly answer, isn't it?
Yeah.
It'd be nice if, style points, everything cancelled and the answer was X, Y, Z. Wouldn't it be nice?
Only if. In
only
a perfect
if.
world, yeah.
In a perfect world, but not this time. That just is what it is. But always be on the lookout for symmetry, especially if you're doing more than one partial derivative, right? Where you're doing a single fx, fy, fz. If the thing's symmetry, can't you just do the horrible answer once and then just switch for the other two?
Yeah.
And this isn't an example of that.